back to DellyMaths Concepts. All right, we have the curriculum-based tests coming up, and I'm going to do a video here. What I want you to do is to like the video, share it so that your friends and everybody share it all over Jamaica, so that everybody can get a quick watch before the exam. Drop a comment also, you know what I mean, and talk about it. If you're looking for online classes, though, whether it's PEP, whether it's CXC, ADMATH, GCSE, GED, FAST, FSA, you can link up this number right here. All right, WhatsApp that number and we can get to you. All right, let us go into the question. It says, examine the set of marbles below. Use it to answer item 1. All right. So let's see what item 1 is. So item 1 says here, which marble represents 50% of the set. So basically what we want to do is just to take a look at how many we have. So we have 1, 2, 3, 4, 5, 6 threes, that's 18 and 4. So we have 22 marbles overall. So there's 22 marbles overall. So we want to know which one of these you could count and get 11 because it's 50%. So let us check off this stripe here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The fact that I get 11 already, that means this is the answer. So that is 11 out of 22. That is 50% already. All right, so A is the answer for number 1. Let's go into number 2. The diagram below represents the number of bananas and mangoes at a fruit stand. So you want to use it to answer question 2. All right, so we're seeing the bananas and the mangoes right there. Look, we're seeing them. So it said, which of the following is the ratio of bananas to mangoes? You want to focus on what comes first, banana. So we're going to count them off. 1, 2, 3, 4 bananas. Let's count off the mangoes. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 mangoes. So the ratio of banana to mango, when the key is telling you that 1 is just 1 banana, 1 of this is 1 mango. So we have 48. So be careful, you know, not 8 to 4, 48. So our answer is D, 4 banana to 1 mango. Next question, examine the stars. Use it to answer item 3. All right, it says, what is the ratio of little star white to black? All right, so you want to see how many white are you looking at? Let's look at 62. For the white one, 1, 2, 3, 4, 5, 6. 6. And I'm seeing 1, 2 black. All right, so that is 62. If you don't see your answer, what you want to do is to break it down. Remember, we could divide this by 2. So 2 into 6 is 3, and 2 into itself is 1. So I'm also looking for 3 to 1, and the answer is here at C. So a lot of times, if your ratio is not there, you want to break it down to its lowest form, and then look. What ratio is equivalent to 3/4? All we're going to do is to cancel down these and see which one will stop at 3 to 4. That can't work. This can't work. I'm going to divide this by 4. So if I divide 12 and 16 by 4, if I divide them by 4, so 4 into the 12 goes 3, 4 into that goes 4. So we're getting our 3 to 4. So the answer is 12 to 16. So basically, you just want to divide them out. And as soon as you see your answer, you pick it because there's only one right answer here. Which fraction represents the result of this? Whenever you're multiplying fractions, if there is nothing to cancel, you multiply top by top, bottom by the bottom. So I'm looking for 5 over 12. I'm looking, and the answer is at A. Remember, when you multiply fractions, top multiply by top, bottom multiply by the bottom. Question 6. Which of the following represents an exponential form in the box? So basically exponential form here is showing we're multiplying 3, so we want to know how many times did it occur. 1, 2, 3, 4, 5, 6. That means we have 3 raised to the 6th power. So we're looking for 3 raised to the 6th power. Remember that the power tells how many times something multiplied by itself, right? Which of the following represents the value of 4,032? So you're looking for 4,032. All right, so definitely we're not liking that. We're not liking that. Those are 400s. So is a 4,302. No, this is off. So the answer had to be this. 4,000 plus 30 plus 2. So that's our 4,032. So be careful of what they want and what you're responding to. All right. So that is our 4,032. The answer is D. All right, keep moving. Which of the following is an infinite set? So you know an infinite set goes on to infinity, it never stops. So factors, they're limited. Multiples of 2, though, never stop. So I like this. This is the answer because multiples of 2 would be your 2 times. And I'm not talking your timetable because your timetable stop at 12 twos, but this goes on to infinity. All right. So 2, 4, 6, 8, da 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 da. It goes on to infinity. All right. So that's the answer right there. Infinite. Which number is a factor of 36? Which number is a factor of 36? Now, remember, a number, the biggest factor of any number is itself. So it can't be this, right? We're positive. Which one of these numbers can go into 36? This is our answer. So those are off limits. Our answer is 12. 12 could go into 36 3 times, right? There we go. All right, so 12 is a factor. Let's keep going. Which number is a prime factor? Right? So prime factor. So what we're going to do is to easily eliminate these because these are not prime numbers. We need prime factor, right? So number 2 here, matter of fact, number 2 is the only even number that is a prime number, and it is a prime factor of 24. It goes into 24 12 times. All right, let's keep going. Which fraction represents 20%? There are many ways you can represent this, right? But what you could do is to represent 20% as a fraction. 20% means 20 over 100. And then you could try to break down this the way, any way you can. For some of us, you may cancel the zeros at the end and you're left with 2/10. And then you could say 2 into itself, 1, 2 into 10, 5. So we're looking for 1/5, right? And then 1/5 is the answer. That is the same as 20%. There are other ways that you could work this out. Some people try to use the answers to answer it, but I'm just doing it one way now in the interest of time. So 1/5. Again, 20% can be represented as 20 over 100. Then I break it down and the answer will show up. All right. All right, let's look at this. It says the diagram blue shows the ratio of the number of boys. All right, so the ratio of the number of boys to the number of girls in the club. All right, and they're looking at it. We got it. It's 3 to 9. Now use the information to answer the question. So the question says, what percentage of the students are girls? Percentage of the students are girls. So the students would have been a total of this. So the total number of students would have been 3 plus 9. So we have 12 students. All right. But the question wants to know what percentage of those students will be girls. So you could represent this like say, okay, 9 girls out of a total of 12 times this by 100 over 1. And it's going to tell you the percentage. Now you could work this out whichever way you're comfortable. For example, let us say we divide this by 3, 3 into 9, 3, 3 into 12, 4, and then 4 into itself, 1, 4 into 100 is 25. So at this moment, you want to multiply 3 times 25. That's going to give you 75 as a percent. Now, I'm not saying this is the only way to work this out, but definitely this is a way that you can use. Find the total in the situation, represent what they want as a fraction of the total. So that is how we put the 9 over the total 12 students, and then we could do it there. Another way in which you could do this, you could split this up into sets of 3s, as you could see here. And then you're seeing that girls would be 3. You could see that the girls would be 3 out of the total of 4 equal parts. So there again, you could see 3/4. Represent 3/4 as a percentage is 3/4. So you're going to get your 75% again. So there are diverse ways to get to the answer, which means that you have options. Take the one that you prefer. Number 13 says the diagram below shows a bar divided into 5 equal parts, as you can see. It represents the number 50. All right. Use it to answer the question. So the question says, how many parts, right, represents 20% of the bar? Now, let us, how many parts? So we could do this a number of ways. All right. So let us say you want to know how many parts represent 20% of the bar. You could say 20% of 50. All right. That's one way you could do it. 20% of 50, you can work this out, cancel this 0 with that 0, this 0 with that 0, and you end up with 10. Now, when you look at this 50 here, you're seeing that it's 5 equal pieces. Therefore, this is 10, this is 10, this is 10, this is 10, and this is 10. We were told it was into 5 equal parts right here. So then this is telling me that 10 would be 20%. How many bars will that be? Well, out of the 5 bars, 10 is simply 1. So you could have just dealt with it like that. And I'm not saying that's the only way you could do it as well. So using percentage, we find 20% of 50, and it should give us 10, and we can see that 10 is actually 1 bar. So you could have done it that way. All right. All right, let's keep going. The diagram below shows a bar divided into 10 equal parts. We see that. The shaded area represented Andy. Okay. The shaded area represents the amount of money Andy spent on game. Use the information to answer item 14. All right. Which of the following represents how much money Andy had spent? All right. So you're seeing, let's take a look. Let's read it today. You want to make sure. It said the shaded area represents the amount of money and spent, the shaded area. Look, so let me just help you to shade, because some of it look a little bit paler. This is what Andy spent, which is 1, 2, 3, 4, 5 out of 6, 7, 8, 9, 10. So he spent 5 out of 10. And then you look, that's a half. And a half of 100 is 50%. So you could see multiple ways to get there. You could simply use logics and get this. You could work it out if you want. But look at the question though. The shaded area represents the money that Andy spent on games. And then it's now asking which of the following represent how much money Andy has spent. 50% of his money was spent. 5 out of 10. Look at this jar here that we're dealing with. It says what percentage best represent the amount of liquid in the jar? Best represent. What you can do is to take a look at what this is. Now, they already tell you that this is 3 out of 4. So we did a question similar already, because 3 out of 4, turn this into percentage. Percentage mean out of 100. From here, you can say, well, 4 into itself is 1. 4 into 10 is going to give you 2, remainder 2. 4 into 20 is going to give you 5. So basically, we're saying 4 into 100 is 25. So if you multiply 3 times 25, that is going to give you 75%. All right. So we're saying that that is 75%. And then again, 3 over 4 is something that you want to know. 1 over 4 is 25%. 1 over 2 is 50%. 3 over 4 is 75%. These are some little stuff that you want to make sure that you have up your sleeve going for this exam. All right. Question 16 says, what percent of 20 is 16 is when the off goes at the bottom and the is goes on top all the time. So basically you're dealing with 16 over 20, and then you want to break this down. I mean, the way in which you want to. Again, remember now you're changing this to a percentage. What percentage of 20 is? So you want to multiply by 100. Then you could take the zeros, 20, take out the 0 at the end, and this, we want to break it down slowly. So there are many ways you could go. You could say 2 into itself, 1, 2 into 16, 8, 8 times 10. And when I said 8 times 10, I'm referring to this 8 times this 10 that is left, and that's going to give you 80. So this is actually 80%. All right. So there you have it. You have an 80% there, not bad. You should be going good, going good, going good. All right, let's keep rolling, keep rolling. 70% of a number is 140. What is the number? So 70% of a number is 140. What is the number? Now, let us look at it like this. If you have 70% and 70% is 140, there's a cool way of getting this out. If you're given a percentage or a fraction of something, reciprocate and multiply, and you get it back. So I'm going to reciprocate. This is just a quick way to get there. So I'm going to reciprocate. I'm going to flip this. Then I'm going to multiply it by the same thing, and it's going to show me the answer. 17 to itself, 1. 17 to 142. The answer is 200. Again, let me just say this. If you're given a fraction or a percentage, so in this case, we get the percentage of the idea, but the percentage can be represented as a fraction. So in other words, then we were indirectly told that 70%, 70 over 100 of something is 140. I'm saying there's a very cool way of doing this. Reciprocate the fraction and multiply by the total you got. It's going to give you back the original. All right. So that's a tool that you can use to get there without guessing. All right, let us pay attention to details. All right, so it says the 3 tables below shows 3 classes, class A, class B, class C. The number of girls in each class is shown, as well as the percentage of girls in each class. Use the information given in each table to answer item 18. So it says class A, number of girls, 8 girls, percentage of girls, 40%. 8 girls is 40%. I still can use this skill to know the total because this is telling me that 40% means 40 over 100. 40% is 8. If I want to know the original amount, reciprocate this, you're going to get 100 over 40. If you multiply this by 8, it's going to take you back to the full thing right now. So you could cancel 8 into itself 1, 8 into 40, 5, 5 into itself 1, 5 into 120. So this is telling me that there were 20 persons in this class, right? 20 persons in this class. All right, so class A has 20 persons. Class B, well, everything is worked out. 8 persons in this class, but 8 persons is 20% of this total that we have here. Not bad. All right, so let's keep going. So in this class here, we have the number of girls, which is 8, but this is 50% of the class. 50% means half off. So that means there were only 16 persons in this class. So let's look. Class A, we're dealing with 20. Class B, we're dealing with 40. Class C, we're dealing with 16. Those are the total number of students in each class. So let us see now which statement is true. Class A has more than class B. This is incorrect. Class B has more than class C. This is correct already. Class C has more than nobody. That's incorrect. Each class has 40 incorrect. So you could see that B is definitely the answer because class B had more, right? All right, let us go to question 19. It says the table below shows the amount of milk in liters needed to make different recipes. So we want to use this information in the table to answer item 19. So here it is. You're seeing, for example, to make bun, you need that amount of milk, 1 1/4, cookies, 1/3, 2 for the milk. And we're talking about liters. 2 1/2 for cheese, 3 1/3 for yogurt. Pancake is actually 1/4. So the question is suggesting that, hey, which recipe here would require 4 liters of milk? So in other words, then for each of these that you're going to be checking, you want to check by adding up to see which ones you're going to get 4 for. So I'm just going to pick on this one here. So pancake. So you'll be checking all of them, right? You'll check them one at a time. So when you check, so I'm going to mark this one. So let us see if this one works. Pancake. Pancake is 1/4. And I'm going to add that too. So that's 1/4. Bun is 1 3/4. And then cake. So I just this, and cake is 2. So let us see. When I look at 1/4 and 1 3/4, this is going to give me 2. Because if I have 1/4 of something plus 1 3/4, again, that's 2. And then 2 plus 2 gives me 4. So definitely this works. So if this works for me at the first chance, I got 4. I'm not going to continue because the aim was to see which 3 would have added to give 4. And if you get it, you move on. If you try it, didn't get it, try another one until you get 4. Luckily, I tried the first one and I got 4. So I'm moving on. So for the next question, it says diagram below shows a bar divided into 10 equal parts. The shaded area represents 3/10. So they're telling us that here, this shaded area that you're seeing, as you could see, it is actually 3 out of 10. You could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're seeing that we got 3 out of 10. Sheldon, the shaded portion is, all right, so these are responses. Sheldon said this is 300%. Jane said it's 33%. Mark, it's 30%. And it is 3%. Which student is correct? So basically, what percentage is this? They're asking you. So you're saying it's 3 out of 10 times 100. Get your answer, and then you could just pick the answer without guessing, all right? So you're seeing this cancel that, cancel that. So then 3 times 10 gives you 30. And then you're seeing that this is 30%. Which one of these persons said 30%? It's Mark. So Mark is correct. So Mark is saying the shaded region is actually 30%. So technically what you're doing is you're working out this for yourself and you match back to see what's going on. All right? All right. All right, let's keep going. It says here the shaded, a student was asked to solve a half plus a quarter. The diagram below shows the steps the students took to solve the problem. So watch this. This is what they're doing. Use the information diagram to show item 21. All right. So use the information in the diagram to answer 21. All right. So half plus a quarter. All right. All right. So good. We're looking at, so you're looking at various, let me see if I could minimize this for you to see. So you're looking at all of that. So the question is saying which, so here's a question though. It says In which representation did the student make an error? So you want to look at which of these representation you're seeing that there is an error. So let us check them quickly. Well, I'm seeing a half, I'm seeing a quarter, that's good. I'm seeing 4/8, I'm seeing 2/8, that's good. Here, this is 6/8, but this is 1, 2, 3, 4, 5. So this was not represented properly. They shaded 5/8 and they call it 6/8. So definitely you could see at step 3 there's an error, right? In the representation of 6/8. This is the error. They did not represented 6/8 properly. They actually shaded 5, right? So you have to look. All right. Examine Erica solution to the problem blue. Use it to answer 22. All right. So, all right. So you're seeing where Erica, so this is the problem, 2 raised to the 4th. Remember now, we are of the opinion, we know that 2 raised to the 4th means 2 times 2 times 2 times 2. All right. Which means 2 times 2 is 4 times 2 is 8 times 2. This is 16. It does not mean 2 times 4, right? It's powers of 2. It's going to multiply by itself that many times. So is Erica correct? No, Erica is not correct. So these are out. Erica is not correct. And B is out because 2 to the 4th does not mean that. 2 to the 4th means what we were saying. So again, we want to make sure that we have these down, all right? Examine the conversation below between Mark and Ariel, right, about the ratio 1 to 5. Use it to answer question 23. It says Mark. So Mark says the ratio of boys to girls in the school is 1 to 5, all right? So this is boys and that's the girls. Ariel says, okay, that means the fraction for boys in the school, in our school, is 1/5. Well, this is not so good right now, all right? Because it's not 5, it's going to be our total because 1 to 5 would give a total of 6 parts. So boys would have been 1 out of that 6. Girls would have been 5 out of that 6. So it's 1/6 for boys. Now let's see the question. Watch again. It says, which of the following? So Ariel says that means the boys is 1/5. All right. So we're saying no, this is 1/6. All right. So which of the following claims should Ariel have made to that? The fractions of that is going to be 1/6. So 1/6, all right, it is 1 out of 6 equal part because, yeah, this is good. The 6 is because it's 5 out of 6. The 6 over 1 because that's 6. No, the answer is 1. The answer is 1/6, right? Because it's 1 out of 6 equal parts. So that's what they should have said. Which of the following is an example of this statement below? The product of a number and its reciprocal. You're looking for a fraction that is reciprocated or flip upside down and multiply by itself. That's not it. This looks good. So here's in 4/3, then it's multiplied by 3/4. That is actually the product of a number and its reciprocal, right? Reciprocal means it flips. All right, read the statement made by a student in the box below. Use it to answer item 25. 2 fractions are always equal if one denominator is a factor of the other denominator. All right, so we're seeing that. It says, which pair of fraction make the statement the student make false? So go back to the statement. 2 fractions are always, this is a big statement here. 2 fractions are always equal if one denominator is a factor of another. So you want to find one of these where the denominator is a factor of the other, but they're not equal. All right. So like this one at D, 5, this denominator 5 is a factor of 10. But if I break down 5 over 10, I'll get 1 over 2. And 1 over 2 is not equal to 1 over 5. So this would have made the statement wrong. So the thing is, so you gotta read to see what they're saying. It says, which of the fraction made the statement made false? False. So based on this statement, this statement is suggesting that if one denominator is a factor of the other, then they are always equal. Well, we just saw that 5 is a factor of 10, but when we break down one fraction, it did not equal to the other. D is the answer. Want to examine this pattern right below. Each term in the pattern is increased by the same number. Use it to answer item 26. So if it is increased by the same number and you want to know that number without guessing, you subtract the 19 from the 26. All right, because you have two consecutive numbers right there, then you could have just subtract those and then see what's going on. When you subtract, you're going to get 7. So basically, then it's telling us that this would be 12 because 5 plus 7 is 12. 12 plus 7 is 19. 19 plus 7 is 26. 27. 26 plus 7 is 43. So as you could see, we were actually increasing by 7. I'm just suggesting that the fact that you got this piece, you really don't need to think because they gave us two consecutive things. So whatever it was increased by, you would have seen it between those two. So if you subtract it, the answer would have shown up just like that. 4 students, John, Lee, Lisa, and Beth, were asked to answer the questions given in the box below. Examine the question given and answer the 4 students provided. Oh, and the answer is 4 students provided. All right, so we're going to answer question 7. It said, Mr. Brown, the teacher of 6A, has a piece of string that is 2.76 long. It was Mrs. Brown. She cut off. Cut off means to subtract. All right. How much is remaining? Cut off means to subtract. So what you want to look for is subtraction. I'm seeing addition. I'm seeing multiplication, division. Those are, I mean, even if this was subtracted wrong, I am going to have to pick that. All right. So because cut off means that you're subtracting. So if you take the 0.9 from the 2.7, yeah. So 2.7 minus the 0.9, you're going to get 1.86. All right. So the answer is John right there. So we're looking for John. Which student has the correct response? John has the correct response. The answer is B. So basically, you want to work out this problem as you go. The diagram below shows how much a tree has grown over a period of time. Use it, all right, to answer item 28. So the tree was actually 3/8 tall, and now it is 1.5. There are multiple ways to look at this. When I look at this, I'm seeing the answer in terms of growth. So the tree is actually this tall now, and it was this. So if you look at the last response, this is showing what the tree was. The tree was, and this is growth, right? This is growth. Let us see if how tall the tree is now. This is 1.5 too, because this is 1. And so this is 1, yeah, 1 whole, and this is 4/8 half. Oh, so you're actually seeing that this was what was, which was in the beginning, this was, and then the tree would have grown 1 and 1/8. That's the growth. So D is the answer. D. All right, so number 28, D. It says here, all students in a class were asked to state whether they prefer Spider-Man or Wonder Woman. Their responses were represented in the Venn diagram below. All right, so we're going to use it to answer the question. It says, all right, so we're looking at the Venn diagram. We're seeing where Spider-Man only 16, then a mixture of Spider-Man and Wonder Woman was 16 people. Spider-Man only was 11, should say, and Wonder Woman only was actually 8. All right. Now, in this case, we don't know who likes this. We know what they like, but we don't know who, whether it's girls or boys. So let's see what they're asking. It says, which of the following conclusions cannot. So not can, cannot, right? Cannot be made from the information given. It says all students in the class like all all the students in the class like either Spider-Man or Wonder Woman. We can know that. Less than half of the students in the class like Spider-Man and Wonder. We can know that. We can know that. More than half of the students like Spider-Man. We can know that by looking at the data. Only the girls. No, we don't know anything about girls or boys. We don't know who like what. So it says only the girls in the class like Wonder Woman. We cannot tell this. This is the answer. So this is the one that we cannot tell. We can tell everything else, but we can't answer to this because none of this was telling us whether it's a girl or a boy that liked it. All right, so we're examining this. We're going to examine this. It says, what is the length of each side of the square? Now, take a look at this. So take a look at the narrative. We're dealing with the triangle and the square. Both shapes have the same perimeter. Now, this is the clue. They both have the same perimeter. So I need to check up 15, and I'm going to add it to 12, add it to 9. I need to add that up. All right, so 15 plus 12 plus 9. You add up that, you get about 36, right? So we're getting 36. What it means then, if I should add up the sides of the square, I'll get 36. 36, and it's equal. So I'm going to just take 36 and I'm going to divide it into 4 equal pieces. I'm going to get 9. So basically 9, 9, 9, 9. All right. So what is the length of each side of the square? It's going to be 9. Because remember, for the square, all the sides are equal. So then I could just divide its perimeter. And we know that the perimeter for the triangle will be the perimeter for the square. So you use it up wisely. A school has 2 water tanks. We're talking about tank A, tank B. They are both rectangular prisms. The base of the tank A is 300 by 300 cm. Tank B is 230 by 350. All right, the height of both is the same. All right, this is very crucial. That means I don't need to do a lot of working. Which statement is true about tank A and tank B? All right, let us see what their base is, right? So you're going to multiply this, you're going to multiply this, right? So when we multiply the 300 times the 300, it's going to give us about 90,000. So 300 by 300, that's giving us 90,000. All right, that's just for the base. And then let's work out the 230 times the 350. All right, so we want to do this quickly. You're getting about 80,500. Now, this is the base. Now, we're talking about having a rectangular prism. Both of them has the same height, but the base is different. So it is telling you that situation A will have a bigger volume, right, than situation B, because this one will hold more. So we're saying tank A will hold more water than tank B. Yes, it will, because it has a bigger capacity. Tank B will hold more. No. Tank A and tank B are the same. No. Tank B will hold half. No. Tank A will hold more because it has a bigger base and it's going up to the same height. The diagram below represents 2 bars of chocolates. We're going to use them to answer the question. Both chocolate bars are equal in thickness. Which statement is true about chocolate bars? All right, let us see how many we have. 1, 2, 3, 4, 5, 6. 6 twos, this is 12. 1, 2, 3, 4. 1, 2, 3. This is 12. So we have 12 and 12. This is equal. Let's see what's going on. Bar 1 has more chocolate. No. Bar 2 has more chocolate. No. Both chocolates have the same amount of, yes. All right. C is the answer for that. They have the same amount. It's both 12 and they're both 12. And we were told that they have the same thickness here. All right, we have two of these triangles are placed together to make a new shape as shown. Use them to answer item 33. All right, so the key here is that it's an equilateral triangle. That means this is 3 and this is 3 cm, just the same. Which of the following is the perimeter of the new? Remember, perimeter does not deal with inside shape, so we're going along the edge, going along the edge. So that is 3 times 4, 12, or you could have said 3 plus 3 plus 3 plus 3. You're gonna get 12. So be careful not to add the inside things because perimeter deals with the distance along the boundary. Mary is traveling from Montego Bay to Kingston by bus. The bus schedule is given below. Use it to answer item 34. Mary has an appointment in Kingston at 3:30, which is 15:30. She wants to arrive in Kingston at least 2 hours before the appointment. 2 hours, at least an hour, right? So she wants to reach at least an hour. Now watch this. 15:30 is the same thing as 3:30 p.m. If she wants to reach an hour, all right, before she want to reach the latest 2:30 p.m., which means that she wants to reach by 2:14:30 if you're looking at that time, right? In other words, she can reach anytime before this. If she reach after this, she's late. So you want to look for any time. So all of these time from here cannot work because you want to make sure that the person arrived before. So the question says, what is the latest possible time that she can reach? So we are referring to the bus schedule. So this one, because she could have reached that time and that time, because if you reach before, you're good. So what is the latest time you can work with based on the bus schedule? You could leave 9 and reach by 1. That's it. Or you could have tried the ones before, but because they said latest, right? Latest, right? So this is the closest time to the cutoff, which is 2:30 or 14:30. So the question is the latest time that you could leave Mobay. So you're still looking at leaving Mobay. Leaving Mobay is 9 a.m. because it's going to let you reach by 1. So you have to be careful of what you're looking at. All right. So what is the actual distance between this? All right. So let's read what's going on. It says here, the line segment below shows the distance X and P on a map. The scale used for 1 centimeter. The scale used for 1 centimeter to 5 meters. So we're looking at 1 centimeter is going to be equivalent to 5 meters. All right. And what is the actual distance between X and Y? So you could see this is centimeter. For every 1, it's 5. So 5 times 10. So that is actually 50 meters for the same, because for every 1, it is 5. So 10 times 5 is going to give us 50. Examine this 6 shapes below. Use them to answer 36. Which solid? All right, this is a rectangular prism. And when we say rectangular prism, we're talking this same thing here. That's what we're referring to. That's a rectangular prism. Right. So in this one, it says how many more units cubes are needed to complete the large cuboid. So in other words, then you could see that some were missing, and you want to know how many more. So the context is how many more, all right, are needed. So let us look here. We have 16 at the bottom because it's a 4 by 4. You could see 4 by 4 we're told. So we have 4 by 4 for the base. We have all 16 at the bottom. Now for the second row, so this is first layer, this is the second layer, and this is third layer. First layer, we have everything. Second layer, you could see that they're missing 1, 2, 3, 4, 5. 5 out of 16. So that means they would have had how many, right? So you could see that they had 11. They had 11 there, right? So we have 11. So in terms of what is missing, none is missing at the first level, right? 5 is missing at the second level. So we're talking, if you're thinking about what is missing here to answer the question, this is what we have, right? But we're focusing on what is missing to complete. If you look at the top, if you know what you have, you know what's missing. We have 1, 2, 3, 4, 5, 6. So we have 6 there, right? 6. So this is what we have, 6, which means out of the 6, hello, 10 is missing. So that means then how many more would we need to fulfill? You add up these numbers, you're going to get 15. So we needed 15 more to complete the thing. 38. Which of the following describes a cuboid? Let's look quickly at the cuboid. So I'm just going to drop the cuboid here. All right, it says it has more edges. Let's just put them down quickly. Edge, face, vertex. Let's count off the vertex here. Let's change this. All right, so the vertex would be the corner spots. Let's write them down. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 vertices. In terms of edges, all right, so we know it has 6 faces already. In terms of edges, I'm going to try to use a blue. So you could see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it has 12 edges. So with that now, you could answer the question. It has more edges than vertices. Well, that's true. This is true already. You could see the others, check them out. It has more edges. It has more edges than vertex and faces combined. No. It has more face than edges. No. It has more vertices than edges. No. So it has more edges than anything else. All right. So you could see that 12. All right, let's keep going. All right, so we're looking at a stem and leaf, and they're giving a quick little key here. So if you see 4/6, it means 46. So this is tens, and this is ones. Okay, tens and ones. All right. So let us see. You want to represent these numbers. So you want to check them off to see which one will you actually have those. So we're looking for, let me look for the singles. There is a 3, there's a 3, there is a 5. I'm looking for error. Let us look. Everybody has 3 and 5. Okay. All right. So there's no 3 and 5 there. All right. So we could cancel that one. So we're seeing 3 and 5 everywhere else. No problem. Let's keep looking. So we see 3, we see 5. Let's look again. We are seeing 13, 2 13s, 1 15. So we're looking for 2 13 and 1 15. That means we're looking for 1 3. This is not 13 here. The 1 will be a 3, so this is out. You're looking for 1 3 1 3. This is looking so good. This look good, that look good. This look good, 2 13 1 15. So we're looking at B and C now. Let's see what else we have. We have 2 25s. and a 28. 225, 128. So I'm looking for 558. This is wrong because I'm only seeing 125. So I'm looking for 558. So this is good. So if this is wrong, then obviously this is good. So it's 30. So 32 and 54 would be our next number there. And you can see the 32 and the 54 here. So C is the answer for that. All right. All right, let's take a look at this last question here. It says, the 40 grade 6 students in the class, there are 40 grade 6 students in class. Which statement is true about the graph? So we have more students have yellow bags than blue bags. Let us look. So we're looking for true. More students have yellow bags than blue bags. Where is yellow? More have yellow than blue. No, blue and yellow is the same. So this is wrong. More than half of the students have either black or gray. So let's go for black or gray. Black, 10. So black is 10 right here. And gray is 8. So 10 and 8, that's 18. And that's not more than half because it's 40. So this is less than half. So this is also incorrect. White is the least popular bag. So that means white would have been the smallest, and it's not. Pink is the least. Pink is the smallest bar. This is incorrect, which means that this is the answer. But let us just verify it. Quarter of the students have black bags. How many black bags? So if you divide the 40 by 4, you're getting 10. So you could see it's true. All right, so that is true. There it is. All right, there it is, there it is. So again, everybody, remember to like this video, man. Like this video. Share it to every single primary school that you know, all right? And drop a comment in the section. And if you're looking for online classes, remember, it's 481-8561. WhatsApp this number, and I'll take you to a good mathematics journey in your PEP, right? So 2025 is coming up. Come on, share the video. See you next time. Bye-bye.